In this question, we have Laplace equation uxx plus uyy which is equal to 0. Now, with the boundary condition given, first x comma 0 which is equal to 0, second x comma 1 which is equal to 0, third 0 comma y which is equal to 0, fourth condition 2 comma y which is equal to 1. Now let's use the method of separation variable. Assume u of x comma y equals to x y of y, substituting into Laplace equation. Here, after double differentiation of x, y of y plus x of x, y of double differentiation of y is equals to 0. Now divide both sides with x comma with x of x, y of y. Dividing both sides, what we will get? We will get x double differentiation of x upon x of x plus y double differentiation of y upon y of y is equals to 0. Now moving further, since the left side depends on x and the right side depends on y, both sides must be equal to constant, which we will call lambda square. What we will call lambda square. So now further solving it, which is equals to minus of y which is equals to minus of lambda square. Since both sides are equal, now we have to separate ordinary differential equation for x of x. For x of x, ordinary differential equation, which we call ODE, is equals to x double differentiation of x plus lambda square x of x which is equals to 0. The general solution, or we call GS, for x of x is can be written as a cos x or a cos lambda x plus b sin lambda x. Using the boundary condition, so boundary condition is u 0 comma y which is equals to x 0 of y which is equals to 0. This implies A cos 0 plus B sin 0, which is equals to A. So we can write A equal to 0. Now for the second condition of boundary equation, we have u 2 comma y, which is equals to x 2 y of y, which is equals to 1. This implies b sin 2 lambda is equals to 1. To summarize the complete equation, u x comma y is a combination of the solution x of x and y of y, and it depends on the values of B, C and D, as well as lambda. The exact value of these constant will be specific values of lambda satisfy b sin 2 lambda is equals to 1.